Hi, Assalamualaikum. My name is Muhammad Amir Hisham bin Razian, and I will present to you about our project, which is the EMC Design Seminar. Okay, we proceed to our slide here. Okay, for our background, which is there is a numerous situation where a company which is they make product which is uh, there was some issue which in the product itself, which is in attention to EMC design principles, has caused disastrous schedule delays and cost overruns for the company itself, and this can be quite harming for the budget of the company. So a one-day seminar will be held at the training room facility to train our engineers and our related staff on designing products that are up to standards with the current EMC standards. So that is our purpose for this seminar. And for the seminar outlines, which is we want to educate and train our fellow engineers on designing an EMC friendly products, which is consists of five five topics, which is five structures on the seminar, which is uh, the design of board layout. First one, second one is filters, third is circuit partitioning, fourth is grounding, and the last one is shielding. So the five main outlines here is the steps to design an EMC product. Okay, so our seminar will be a one-day seminar only. So we will have to utilize all of our working hours from 8 a.m. to 6 p.m. And the seminar itself will start at 8 a.m. and have three breaks, which is on the breakfast and at 10 a.m., lunch, and also tea time at 4 p.m. And then consists of three modules, which is the first modules will be uh, module 1, which is board layout and also radiated emission and EMI filters. So that is basically covers the whole morning sessions. And then in the afternoon, we will have module 2, which is the circuit partitioning and also grounding. And then in the evening, we will have module 3, which is the shielding topics. Okay, now we will proceed to the module content itself. So me and my friends will present more or less about the contents of the three modules that we have created. Okay.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Nimko, and I will present the first part of the seminar. Model 1, I will take model 1, which is about the board layout of radiator emission and filter is used. This is the content, and which like introduction, radiator from BCP, radiation emission in EMC, differentiation of differential mode current and common mode current, sources, also filters, and so on. If I start, noise produced by the circuit that radiates wireless to other parts of the system is radiator emissions. Radiator emission to EN 50 require the EUT to be positioned so that in boundaries the specified distance from the mission antenna. Boundary is defined as an imaginary straight line, preferably described in a simple geometric configuration, which encompasses the EUT. Table A tabletop EUT should be 0.8 meter nm, and floor standing EUT should be insulated from and up to 15 centimeter above the ground plane. The EUT will be need to be rotated to 360 to find the directions of the maximum emission, and this is usually achieved by standing in on turntable. If it's too big for turntable, then antenna must be moved around the periphery while the EUT is fixed. If we see the radiation from the PCB, in most equipment, the primary emission source are current is flowing in a circuit, like locus video, data drive, and like locus video and data drives and other oscillators that are mounted on PCBs. Radiated emission from a PCB can be modeled as a small lobe antenna carrying the interference current, as a small lobe is one whose dimensions are smaller than the quarter wavelengths at the frequency of interest, example 1M at 75 MHz. Most PCB lobes contain as a small at emission frequency of up to a few hundred megahertz when the dimension approach as quarter wavelengths. The current at the different point on the loop appears out of the phase at a distance, so that the effect is to reduce the field strength at any given point. Also, the maximum electric field strength from such loop of a ground plane at 10 m distance is uh, proportional to the square of the frequency. And here we discuss the common mode and differential mode radiation from cable and present the measurement result from the SMPS connecting wires. Radiative emission in EMC, a commonly encountered geometry in EMC problem responsible for radiative emission is that of a common mode or differential mode current flowing on parallel wire or on parallel PCB lines. The far field is radiated by this geometry are easily determined using the pattern multiplication theorem for antenna array. Radiative emission measurement principle. Radiative emission test is to determine whether the intended product is below a certain level of unwanted electromagnetic frequency. If the measurement result of a product is under the limit value stated on the standard, this test is counted as pass. If we see the filter can help with a variety of can help with a variety of application, but are especially useful for low frequency signal lines, such as power input cable or lines that carry status voltage. In this instance, EMI filters can remove the high frequency element, leaving on only low frequency on the line that generates much less radiation. And I will complete in there for my presentation. Thank you for your listening. Thank you so much, Tito.
Bismillah ar-Rahman ar-Rahim. First, I thank Allah, and the second, I thank in our lecturer, Dr. Assalamu alaikum rahmatullahi wa barakatuh. And this is our project in module 2, circuit versioning and grounding. My name is Amal Hassan Usman. And content title, introduction, versioning, level, problem formation, versioning continuous, random selection, and growth cluster, hierarchical clustering, unique algorithm, performance versioning, grounding, restoration, grounding, and summary. In circuit version is a task of dividing circuit into smaller parts. Circuit version is an important aspect of layout several reasons. Version can be used to directly divide circuit into portions that are implemented in separate components, such as printed circuit board or chips. Here, the objective is to partition the circuit into parts such as that the size of the component are with prescribed ranges, and the complexity of nation of variant complexity is attribute to each net in the circuit some conduction cost and, some cost it may net express or net connecting different component. The conduction cost of net may express such as parameter as the bus width of the net, that is the number of bits have be sent across in parallel, or the connection cost by several to assign higher priority to the nets that should not run across components. And this is in picture a good PCB laid for typical digital system, and because they have in this power RAM and ROM microprocessor, oscillator controller, ASIC, driver output, DIB thread, and this connector, DIB thread and power connector. This is in PCB digital system. And this different level can be done multiple level, system level, board level, chip level, delay implication, and different interchip, interboard, and inner board. In this picture, and creation of quiet firmware connected at the PCB that allows active information of shield and filtering of port cables. This is of port cable. This you see in of port cable, white and ground, RCB package or DIB trap, signal point connection between ground and system. In this high speed component, minimal speed component, and noise digital in analog ground. And this problem information partition a given netlist into smaller netlist such that interconnection between partition is minimized, delay due to partition minimized, number of terminal is less than predetermined maximum value. The area of partition remain in a specific bound, and this place in crystal oscillator close to device itself standards to reduce the loop area and attenuation of interconnected line. This is microprocessor and this is oscillator. Version in technique was probably two classes algorithm: constructive random. Constructive have random selection, cluster growth, hierarchical cluster, and iterative improvement, minicut, simulated annealing. This random selection notice of one at a time place and the cluster of fixed size until the proper size is reached. Repeat above procedure until all nodes have been placed. Quality performance, fast and easy implement, generally produce poor result. Usually used to generate initial partition of interactive placement algorithm. And this in classical cluster and starting with a single node and add other nodes to partition based on connectivity. Hierarchical cluster. Hierarchical cluster is a set of fixed group, then depending on the some measure of closeness. The closest objects are clustered first and considered to be a single object for further in versioning. The process continues by grouping two individual objects or an object or a cluster with another cluster. We stop when a single cluster is generated and hierarchical cluster tree has been formed. That tree can be cut in any way to cut in cluster. This hierarchical, this minical algorithm, is basically algorithm to input version 2 into two sub equal size. Tile cut keeping improving vertex and this vertex and the locket. If no improvement possible, some this performance of driving version in performance. And one board delay is much longer than one chip delay. One chip delay is older than no nanosecond on board. In this millisecond, this is all of goal of version high performance system: reduce the cut size, minimize the delay, critical path, timing constraint have satisfied. This is the picture the important concept of loop in minimizing radiated emission of the power distribution circuit: large loop, smaller loop, use of an inner plane in multiplayer in BCB. This loop area, smaller loop area, and ground plane. In ground in EMC, when we see a ground, it creates a commercial a computational point or plane that serves that the reference point of all other components in the circuit. Is the low impedance that that in the circuit of the current return single source. The three main objectives of EMC grounding to minimize the coupling interference, emission, and escapability. This installation ground of the system with several cable, cabinet PCB and PC1, and this cabinet single ground and higher grounding or earthing. This is an illustration of use ground circuit to minimize the loop. And this like A and B. We minimize like in loop. This is important consideration loop area minimize distribution of power distribution circuit large loop and B. This loop area ground smaller and ground plane. Use of internship ground return on block bands to reduce loop area large area to reduce this we use in this clock we use in reduce in loop area large loop area and reducing loop areas. This illustration of generation of common mode current or interconnect cable due to different ground voltage. This is ground 1 and this is ground 2 and this is the return. Ground problems between along digital a case where because the location of connector the noise analog signal will not return through the digital ground analog system. This an analog and this digital low level analog high level ground in motor driver. This illustration of the problem single point ground common impedance coupling low niche connection and ideal signal point ground connection. This saturation of ground ideal arrangement BCB layout of ground system. Signal ground, noise ground, high level hardware ground. This in analog and digital. And this in our circuit our project summary of successful EMC design, component selection and placement, connector placement and filtering, ground grid, GCHE treatment long and high frequency connection, cable routing, coupling, capacitor placement and selection, treatment of in pressure enclosure, intelligent disaggregation of the various ground system. And this and thank you very much. Thank you for my tutor.
Okay, now I will uh, present and explain more about the module 3, which is that we have created, which is the shielding module in the design step. So in module 3, which is we basically we are learning more or less about how can be described as an effective shielding, which is the shielding effectiveness. So actually, shielding effectiveness is a sum of three particular losses, which is the wave reflection, the absorption, and also the reflection losses caused by the molecular structure of the material itself. So we will proceed to module 3. So we have several topics here, which is our wave propagation. We want to recall that, and then the characteristics of impedance, and also our main topic is shielding effectiveness. Okay, so now one of the topics here we will recall about wave propagation on how the basics of wave propagation itself, and then the characteristic impedance we will learn more about that, and then onto our main topics that we want to highlight in this area, which is the shielding effectiveness. We will teach more on the basic calculations and equations for in order for our engineers can which is analyze what materials that they suppose to use and on how to achieve that great effectiveness in shielding. So, shielding effectiveness consists of three components, which is the absorption loss, the reflection loss, and also the reflection loss, multiple reflection loss, so B. So this is uh, sorry, okay. This is more or less about on the overall of this chapter itself. So we will teach our engineers and technicians and staff to to calculate the, the value of leading effectiveness so that they can come up with reasonable solutions for the designing process. Okay, so on top of that, we have our calculations, and we will also provide some examples as well. And here is the how shielded enclosure works. We will teach our engineer that, and then all of the steps and also the process of VLF shielding here will be also be teach to our engineers, and then some of the examples and ideas on how to install, and also what types of materials that use, and yeah, so that is basically on module 3, because module 3 is not quite long as module 1 and 2, so this module will be very simple, but uh, effectively uh, can be teach to our engineers so that they can have a better idea or better vision about how to design the shielding. Okay, so I think based on that, we have covered all of the modules. So I think that is all for our seminar uh, talk that we would want to present to our fellow engineers. So basically, uh, I, me, Amirul, would want to say thank you to our organizers that give us this opportunity to teach the engineers. So thank you.